Hi, I'm Mike Rowan. Welcome to Part 7 of Retro Printing for Fun and Profit, sharing new and old printers with new and old computers. In Part 7, we will look at automating printing from the color computer. We created a process to capture the color computer's printer output and save it into a file on the Raspberry Pi. Now, we need another process that can monitor that file and print it automatically to the printer of our choice once the output is finished. We're back at the terminal for the Raspberry Pi Zero. We created our cap CoCo.script to capture the output, so we've set the speed and the device that we want with some settings, and then we've captured that data from the serial port into our output file output.dat. Now we need a process to monitor the output.dat and send it to the printer. So to do that, there's a set of utilities called iNotify tools that we can install that will give us commands that will allow us to monitor a file's state and respond when it's been modified or when it stops being modified. So we'll install that. That will be sudo apt install iNotify-tools. And we'll answer yes, we want to install it. All right, we have the iNotify tools installed. Okay, so let's see how iNotify works. Created a script called test2.sh. Let's take a look at what we have in there. So I've spaced these lines out so they're easy to read. So first we're going to start off by echoing to the screen, watching output.dat. And then here's our iNotify command. And that's going to watch this file for output. Let's take a look at the man page for iNotify wait. Now what it does is it waits for changes to a file using the iNotify tools that we have installed. I'm going to skip down to the events so we can see, well, what kind of things does it watch a file for? And, what types of things triggers it. So we can trigger it if the file has been accessed. We can trigger it if it's going to be modified, which is what we're going to use. You can monitor for attribute changes, close write, close no write, open, move to, move from, move self, create, delete. So there's all kinds of things that you can monitor files for, a very handy tool. But we're interested in modify. A watched file or a file within a watched directory was written to. So that's what we want to trigger our script here. So in the test script here, we're going to say iNotify wait -t0, -t is the time. How long will it watch the file? For what period? Will it watch it forever? Will it watch it for 10 seconds? In our case, 0. It's going to watch it forever. -q is the quiet option so that it limits the output. And then -e is to specify an event. The event we're going to specify is modify. And finally, what file are we watching? Output.dat. So what this is going to do is it's going to watch the output.dat file continuously until something happens, until it's modified. Once the file is modified, it will jump out of the iNotify wait and it will execute this command to tell us the file has been modified. First thing we have to do is make this executable. If I do an ls-l, test2 is read write, read read. We need to change that to change mode to 700. That will give read write execute to the owner, which is Pi. And now we see that it's read write execute. It's got the execute bit, and we see it in green here on our screen. All right, so let's run that script. All right, so it's sitting there watching output.dat. So it's going to sit here forever until we modify output.dat. Right now it's a 0 size file. So let me get out of this man page. I'll just echo test and I'll append that into output.dat. So this would simulate the color computer printing, for instance. So as soon as I hit enter here, we should see this jump out at in the other window. And there we go. So our script detected that there was a modify to output.dat, and then our message is printed. The file has been modified. So that's going to be the first trigger in our script. Let's further modify our test script And we're going to add some more lines. So here are the lines that we added at first. Now we're going to say, okay, so we've detected that it's being modified. Now what I want to do is I want to wait until the file stops being modified. So if the color computer starts printing, I want this program to wake up and say, oh, something's coming into this file, so I should pay attention to it. And then what I want to do is I'm going to create a while loop. So we'll do while this happens, do this, and done, repeat it. So here we're going to say, we're going to use the same command, iNotify wait, except now we're going to use -T10. So now we're going to put a 10-second limit here, which means the iNotify wait won't run for more than 10 seconds at a time. Now it can be triggered before 10 seconds, but it won't run for longer than 10 seconds. We want to look for any modification on output.dat. And then I added this to direct any output from that command to dev null so that we don't see it on the screen. So what should happen is, as soon as this starts, if data is coming in, it's going to see that the file is modified, and it will immediately say, oh, I see it modified. It's going to break out and do the actions we have here. In this case, we're going to echo, it's still being modified, and then we're going to sleep for 1 second. And then when it gets to done, it'll go back up and do it again. Essentially what it's going to do is, while the file is being modified, while the printer data is coming in, once a second it's going to loop back to the top and loop back to the top and loop back to the top until the data stops. Once the data stops, the file will stop being modified, and that's where this 10 seconds comes in. So the last time that it triggers, the file stops, iNotify wait will wait for 10 seconds. And if the file has not been modified in 10 seconds, it will break out of this loop, and then it's going to print file is no longer being modified. All right, so let's test this with actual data from the color computer. So we need to start our cap CoCo script so that we're capturing data from the serial port. And then we will start our test2 script so that we can watch the output file. And now when I press, I'll run an list on the color computer. All right, we also want to make sure that our color computer is set up to send at 9600 bits per second. So we'll do poke 149, comma 0, poke 150, comma 1. That'll match what we've got in our capture program. And I've got a program in here. Big long program. Okay, we'll do an list and send that. Now we can see that it's in that loop where it says it's still being modified, still being modified, still being modified. So the data is coming across from the color computer right now. And we're sleeping 1 second before we go back and loop again. Okay, now it's hit the place where it's stopped being modified and we're waiting the 10 seconds. So if it goes 10 seconds without being modified, it will break out of the loop, and here we go. File in no longer being modified. That should be is. File is no longer being modified. So at this point in our script, that's when we could trigger doing something with file, like sending it to the printer. So let's add that part now. So if we VI our test2 script, we can do a couple of things here. First of all, I'm going to copy that file. I'm going to copy output.dat to printer.out. Then I'm going to clear out output.dat by writing basically nothing to it, so that will zero the file out without closing it, because our cap CoCo program is still running out here, and we want it to run forever. Okay, so once we've done that, then we can do an LP-D. Let's see, which printer do I need? Let me jump out and see. LP stat -P. I'm going to use my laser printer. So I'll copy that. So LPD to our brother laser printer, and then I'm going to print printer.out. Actually, let me add one more thing to that before I run it. We will add echo printing the file now. And let's go ahead and put file has been sent to cups to end our program. All right, so we still have our capture program running in this window, and here I will run test2.sh. All right, we're watching the output. So now we'll print from the color computer again. All right, we'll do another list. All right, so we see the file still being modified now. So our program's been triggered. I printed just a few lines. All right, so its file is no longer being modified. It's printing the file now. We see that the request was sent to our brother printer. The shell says file has been sent to cups, and it exited the program. And I can hear the print beginning to process on my laser printer. So, with our two programs, CoCo.sh captures the data, and test2.sh will monitor and print our data. But obviously, we don't want to have to manually start these programs every time we want to print from the color computer. So in our next episode, we'll cover turning these scripts into a more fleshed out version with a control program for starting and stopping these processes, as well as a process for starting everything at boot time so that it's running continuously on the Raspberry Pi Zero. Well, this is the end of Part 7. We should have a polished set of programs ready in Part 8. And as always, thanks for watching.